join the discussion document.
Right.
And so here's the scoop. Very briefly, as was described in this email, we arranged for Amelia to think about an issue, and we decided on data science moves in CODAP as the issue. And then we sent out an invitation to a bunch of you, and you guys accepted. And so we're here for the next couple of hours with a break. Don't let us forget to take a break to talk about the issues raised in this paper and other things as they come up. So we're not restricted solely to those issues, but that serves as a framing for us. We're going to introduce each other because not everybody knows everybody. And I've made a list of people here, and if I've left your name off, please add it. And we'll call Amelia the discussant, though that's not really correct. She's like the author, I guess. And I will be the facilitator. If I'm too heavy-handed, let me know. Talia will record things. Can you record in this document, Talia?
Let me test. Yes.
So that would be a good place. So we see what, those of us who are tracking the document, will see what's being recorded. And so I think you all do know me. And let's go in the order that things are listed in that document. So that would be Talia is next, to introduce ourselves very briefly.
Okay. Hi, I'm Natalia St. Clair. I go by Talia. I'm the research assistant and project coordinator for CODAP, and I started last March. And prior to that, I was studying educational technology at Harvard Graduate School of Education, and I've been teaching middle school math for 7 years. And I also have a personal interest and love of making math beautiful, so CODAP is very interesting and applicable to me in that sense.
Jonathan?
Hi, I'm Jonathan Sando. I'm a developer on the CODAP project.
You're the lead engineer, in fact. Tim.
So I'm Tim Erickson. I'm a freelance math and science educator here in the East Bay, and I am the game developer on the data science games project. So I create the prototypes for data science games.
Co-designer of Fathom.
Co-designer of Fathom.
Very frequently co-designer of
features and stuff.
Yeah.
Because I'm interested in many of the issues that Amelia has brought up in her paper, and the whole issue of tidying data and stuff like that is something we are very concerned with.
And next would be Joachim.
Okay, hi, that's me. I'm a visitor from Germany, visiting here, Concord West. And I'm involved in a project that uses Fathom Tinkerplots and also is highly interested in using CODAP. A project that is focusing on teaching about analyzing social data.
Okay, Dan?
Oh, I don't think there's a mic on where he is.
I can't hear you, Dan.
Can you hear me now?
Yes.
Dan Damelin, I'm with the Concrete Consortium. I'm a co-PI on CODAP with Bill. And I've worked with Bill on this and several other projects.
Cliff?
Cliff Canold, and I work on the CODAP project, both some design work and on the research teams, and former developer of Tinkerplots.
Holly Lynn?
And I'm Holly Lynn, and I'm really trying to fix my video, but it's not working. But I'm a professor at NC State University in mathematics and statistics education. And I have been a longtime user of tools like Fathom and Tinkerplots, particularly in teacher education, as well as with research with students. And I am the PI on a grant where Bill is a co-PI, where we're going to be taking CODAP further for developing some modules in statistics teacher education.
And Michelle.
Hi, I'm Michelle. I'm an assistant professor at the University of California at Berkeley. I'm interested really broadly in how kids make sense of data, especially through data visualizations that are wacky and that we don't learn about in school. And I'm also working with Bill and Tim on the Data Science Games project.
And Kirk? You're muted. You are muted, Kirk. We cannot hear you.
We still can't hear you, Kirk.
Button debouncing problem.
Oh.
Kirk Swenson, software engineer at Concord Consortium, and at various times lead engineer on Fathom and data games before it became CODAP.
And Amelia.
I think we might have missed a couple people who are on the chat, but I'm happy to introduce myself. So I'm Amelia McNamara. I'm a visiting assistant professor at Smith College in statistical and data sciences. My dissertation was about statistical computing in the context of education. So I kind of think about critiquing software that people use to do and to teach statistics.
And we missed Rob because his name wasn't on the list, but now it is.
I'm Rob Gould from UCLA Statistics, and I've been involved in quite a few educational projects with many of you, so it's great to be here.
Oh.
The other name I see at the top of the chat is Evangeline.
Oh.
I stayed here because I figured it was crowded in your room, Bill. So I work with the CODAP project with Bill and Jonathan. I'm the software test person.
Yeah, so we have quite a range of perspectives and expertise. So I thought we should spend a few minutes on background, and I have something to say by way of background, and then Amelia gets a chance to lay out stuff in addition to what we are assuming everyone has read the paper in these discussions. If that's not the case, we won't know it. So you can speak as though you have read it. And then we'll go into free-form discussion, maybe organized around the questions that Amelia kindly put at the end of the paper, which are listed in the discussion document. So I wanted to talk about the P in CODAP, which is platform. And I think it's a difficult idea to keep in our minds as we talk about CODAP, because we're all pretty accustomed to using products. So P is for platform, not for product. Many of us have thought about designing something that will be used in the classroom for a stats class or a math class or a science class. And while it's true that that CODAP is being, and we want it to be used widely in classrooms in those various classes, as a project, it's a platform that we expect others to build upon for those uses. And so in the discussion today, we have to think about it from that perspective. And that's all I wanted to say about the P in CODAP.
Can you just say a little bit more about what you mean by that, by platform?
Okay, good. I thought it was obvious. So a platform is something that's ready for you to climb up on and build on top of. So in some instances, it's a library. So a bunch of stuff that you can use in the code that you're writing to make new things happen. In the case of CODAP, it's more than a library because it's already an environment, and many of our collaborators simply make use of the environment. Tim is involved in a project that has a proposal in that hasn't even contacted us. And they are planning to make use of CODAP kind of as is, but with Tim's help, extending it through data interactives. Does anybody want to add to that? What a platform
Can I ask a question and maybe give an example? So Bill and I, it was a couple of years ago now, talked about, so I'm developing a programmable sketchbook so that kids can create data visualizations starting with sketches. And we played around with the idea of actually having that become a panel that can live, or, you know, I create that tool in a way that it can be loaded into the CODAP system and use the facility that CODAP already provides for working with data, observing data, dragging data onto the programmable screen. And I don't know if I should ask questions along the lines of what we would need CODAP to do in order to make that possible yet, or if that just can serve as another example of how it functions as a platform.
I think if those things come up in the context of this discussion, you should raise them. And it makes me aware that I haven't made it completely clear that one of the ways you can use CODAP as a platform is to build what we call a data interactive. So a data game is an interactive that lives in CODAP but is not an intrinsic part of CODAP. And data sketch, the sketchbook, could be such a thing. In Holly Lynn's project, we're talking about the sampler, that in the Tinkerplot sense of sampler, as living as a data interactive in CODAP and generating data that streams into CODAP.
I do want to, I know you mentioned it some, Bill, but just to provide specific examples of the platformy nature. So in that sense, all of those examples are things that you build and you stick into CODAP, and then CODAP can talk to them, and it's sort of like CODAP is the surround and this is the thing there. We do have examples in which the thing itself kind of takes over the CODAP frame, and so that it's, in a sense, CODAP is more like a library, because you can call CODAP and say, make a graph based, like you could create your own whole CODAP UI, like a whole new version of it if you wanted to, in this thing that takes over the whole canvas. And we've also been talking about having it, in another project. It's not a funded project, but one that we're potentially writing a proposal for, in which, as long as CODAP is on the same web page with other stuff that's going on, things could feed into it. So CODAP retains its own kind of separate identity from whatever other web environment is around it, but could also interact back and forth that way. So we're trying to build CODAP in a way that it's very flexible. I think the difference, a platform is also a product, but I think that in my mind, but the difference is that we want to build it in such a way that flexible usage allows those who are interested in the capabilities of CODAP to build it into the kinds of projects that they want to do in whatever way that they feel like they're not limited to the way that we make them do it, which, up to the point of you can have a data interactive and stick it in CODAP. Well, that was kind of the only way you could do it for a while, and now we're expanding options and ways for people to integrate in different ways.
I would just like to add to that with my emphasis in teacher education, one of my major goals is to put tools in the hands of teachers who can then use them as easily as possible in the classroom. With the new Esteem project down the road, after we get some CODAP functionality expanded, we really hope to be able to have it in such a way that the teachers that are being prepared through the curriculum materials that we develop to use CODAP are able to create their own CODAP files and very easily be able to take them with them, create a library of CODAP created lessons that teachers, pre-service teachers and teachers write so that they can easily go and use those in their classroom, and to be able to perhaps have then a shared library of these kinds of CODAP-enabled teacher-generated tasks that can live on.
Great. I think that's a useful background perspective of what we're talking about today. And now I'll turn it over to Amelia for, we might say, preliminary remarks before the discussion begins.
Okay. Well, I don't have anything particularly prepared, but just as an overview about what I wrote, which again, we're kind of assuming that you all read, I took this data science cycle, which came from Hadley Wickham and the R community, which has import, tidy, transform, visualize, model, and communicate. And I'm arguing that you should be able to do all those things in CODAP, which I think is the first question. Is that true? Do we agree or disagree with that? And then I took each of those and sort of expanded more on how I see CODAP currently, or the way I could imagine it proceeding based on what I know about Tinkerplots and Fathom, how it fits or will fit into that category. So I think for me, the one where there was the least support in the current functionality is the transform step, which is a big part of data science, is manipulating data, doing data cleaning, reshaping data, things like that. And so again, I just am using an example from R, which is an R package called dplyr, which has these few verbs that you can put together in different ways. And I'm saying I think that CODAP should be able to do all those verbs, hopefully in some visual way. And then I thought a little bit about how that might look. And there were a few references to videos. So if I can make it work, I might just show a couple minutes of video clips.
And it will work, Amelia. And there is a check button that you should make sure you check, which is to about streaming the sound through the monitor.
Okay. So we'll see. I've never done this before, so we'll see if it works. So I want share computer sound. Your internet connection is unstable. We'll see. No, I don't know if I've lost you guys. I have to put in my computer password.
You can still see things.
We can tell you're getting ready.
Okay. Okay, so the first video
Actually,
is...
we don't see your... Oh, there we see your screen.
You can see my screen?
Yes, the whole screen.
That's probably all right.
So to begin
and let's see if I can full screen this, because that'll probably make it nicer. So this is a video, and it's Brett Victor, who I kind of describe as a computer futurist, and he's talking about his driving principle, which is like shortening the loop between making modifications in code and seeing the results. So I think I just wanted to show like a minute of this, and we'll see how it works.
Let's think about coding. Here's how coding works. You type a bunch of code into a text editor, kind of imagining in your head what each line of code is going to do. And then you compile and run, and something comes out. So in this case, it's just JavaScript drawing to a canvas, and it draws this little scene with a tree. But if there's anything wrong with the scene, or if I want to make changes, if I have further ideas, I have to go back to the code. And I edit the code, compile and run, see what it looks like. Anything wrong, I go back to the code. Most of my time is spent working in the code, working in a text editor blindly, without an immediate connection to this thing, which is what I'm actually trying to make. So I feel this goes against this principle I have, that creators need an immediate connection to they're making. So I tried to come up with a coding environment that I thought might be more in line with this principle I have. So what I have here is I've got this picture on the side and the code on this side. And this part draws the sky, and this draws the mountains, and this draws the tree. And when I make any change to the code, the picture changes immediately. So the code and the picture are always in sync. There's no compile and run. I just change things in the code, and I see things change in the picture. And now that we have this immediate connection between the code and the picture, we can start thinking about ways of changing the code other than typing. So for example, this number here is the length of the branches. If I want to control that number, I just point my mouse to it, hold down the control key, and I can dial it up and down. So I can see what it looks like for big branches or small branches, and I can kind of converge on what feels right to me artistically. And this works for any number of the code. I just point to it, dial it up and down. And some of these numbers here, I know what they do, but it's still kind of surprising to see them do it. And other ones are just completely surprising. So down here, I've got this for loop where I'm counting to 16. I'm putting 16 little pink blossoms.
Okay, so I think I'll pause that there, and then I'm just going to see if I can get to the next little segment that I wanted to show, which I think was here.
But there's still a problem here, I think, which is I've got this picture, and I've got this code over here, and I have to maintain the mapping between the two in my head. So I've got all these lines of code, and just looking at this line, I don't immediately know what it does. So here's what I can do. I can hold down the Option key, my cursor changes to a magnifying glass, and now as I roll over each line of code, it's highlighting in the picture what's being drawn in that line. So if I want to know what's going on in this function, I just kind of roll down the function and see what highlights. So here I've got two calls to draw a mountain. I don't know which is which. Well, that's that mountain, and that's that mountain. And this has to work the other way, too, that if I see part of the picture, I need to know what code was responsible for drawing it. So I do the same thing. I hold down the Option key, and now as I move over each pixel of the picture, you'll see on the right, it's jumping to the line of code that drew that pixel. So that drew the sky, and that drew the tree, that drew the blossom.
Okay, so that's what I wanted to show from Brett Victor's talk. Then the other thing that I wanted to show, I assume some of you are familiar with KidPix, but this just like is sort of a nice platform that I think of in terms of contextual menus. And I have this video of a talk that I saw the creator of KidPix give, and he's sort of showing the contextual menu. So I thought I'd just show a little bit of that video as well.
You can actually use the real thing. So we've got the tool that draws regular old lines. We've got a tool that draws straight lines. Now, one of the things that was done at that time was that if you wanted to have a bunch of options, you would put a bunch of options in a menu. Well, for the target user, for KidPix, menus were hard to use. And so I went with this system, and I think it's now called kind of context aware, where when you change the tool, it changes the options down here. So you get 14 different options. So that way the program can have a whole lot of possibilities, but at any given time, the screen is still very simple.
Okay, so I think I'm going to stop sharing my screen and leave that be for now. There's also a Shiny app that shows some data manipulations and in R that's a nice visualization. And I think the link that I put in my little paper document is actually outdated. The more recent one is in the document. And if that comes up in discussion, we could, I could demo some of that too if you'd like me to. but it's sort of more advanced versions of the image that I included in the document about summarizing data and having sort of a visual metaphor for doing that. So I think my goal in terms of writing this paper was to sort of provoke discussion, and I'm sort of stating these hardline opinions like CODAP should support this entire cycle of things, and it should support all these same operations that the dplyr package in R supports, but it should do them visually and make this quick and reactive connection between the actions that you're doing and then the results that you see. And perhaps we don't all agree about all those things. So I think that's what the discussion should be about.
I told Amelia that we wouldn't pay her if she didn't provoke us. So, Amelia, how about we start with that first question, because I think it is a really important thing to talk about.
Yeah.
Should CODAP support the data analytics cycle of the tidyverse? Is it appropriate for a tool for learning? And we know your position now. Would someone care to take the opposite opinion?
Well, I won't take the opposite opinion. I'll support it. I think it's really important. I think it might really be worth, though, thinking carefully about how it really kind of ties into notions of modeling and that sort of stuff within whatever level you're talking about using it. Because otherwise, I could see it becoming just another set of obstacles itself. I mean, but I think, you know, I think that, especially as Amelia points out, the transform, I mean, I think that's a really important set of tools to be able to give students. And I think like Hadley's own stuff, you know, when he demonstrates working with the airport data, all that story, it really shows you how powerful an analysis tool, simple things like sort, can become. So I think you know, it would be a nice thing to support.
So I think that you know, CODAP does all of these to some degree, although I would say the tidy part actually maybe not. And I guess one of the questions is, given data or particular data sets, it seems like you often need to know quite a bit about a data set in order to make it tidy. and it's pretty idiosyncratic often to the particular data set. And I wonder, I don't know if other tools or what kinds of things that other tools do that make it, that facilitate tidying data, or if we actually think that students should be spending time tidying data because it's an important part of, you know, what data scientists end up having to do, or some data scientists, I guess, probably even compartmentalized, you know, depending on what your specialty is, in terms of the analysis side of things or the collecting and structuring and organizing data side of things.
Yeah. So one thing I'll say is when I think about tidying data, I'm thinking about the tidy data definition set out by Hadley Wickham, again, in the R community. So tidy data is data where each row is an observation and they're all at the same observational level, and each column is a variable, and they're all, like, nothing is smushed together. And so the only place where I think that data in CODAP might be untidy is if it's hierarchical data, because that sort of breaks the idea of tidy data the way that I think about it. I think what you were calling tidying data, I would call data cleaning, sort of like neatening up the variables, or, you know, changing strings to categorical, or whatever it is.
Do
Sorry.
Do you think in CODAP with the hierarchical tables, in a sense, it's linked tidy tables, which is sort of what we have now?
Yeah.
At each hierarchical level, we have single rows, columns are single variables, that kind of thing.
Yeah. Yeah, I don't think it's a bad way to represent data. And I mean, I think many of the people on this call have done research about how hierarchical data is actually a little more natural for humans. So I think that that's great, but it does, you know, like it pushes the idea of we should just do everything that's possible in R in CODAP. Like R doesn't work very well with hierarchical data. So like some of those data operations might not work on hierarchical data, or we'd have to think about how they would work.
Yeah, I mean, I think educationally the big threat with hierarchical data is always that it makes it not only tempting but almost automatic to kind of aggregate across groups that shouldn't be aggregated across. And so having this kind of making explicit this tidying where you're really having to specify, am I analyzing, to go back to an old example, am I analyzing schools, am I analyzing students? I think is a good habit that we want people to start to think about.
Regarding the first question about the full cycle, you model as part of the cycle, and it's not really talked about in the paper, so I didn't know if you wanted to expand on what you meant by that.
Yeah, so I mean, when I think about modeling, and I know this is another sort of term difference, like I think of tinker plots as not supporting modeling because it doesn't have linear regression or multiple regression. People who are more in the stats ed or math ed community, I think, believe that tinker plots supports modeling behavior, and maybe Rob could speak to that. But Fathom, I believe, does support statistical modeling because it has a linear regression and multiple regression feature. And so I was just sort of assuming that because Fathom has that feature, that it was sort of on the list of things to do for CODAP to add linear modeling.
So it was basically statistical modeling of the data set.
Yeah, that's what I think of in that cycle.
Yeah, and since you mentioned me by name, I guess what I would say is the
It's
terminology.
Like the debate, right? Like you were mentioned, so you can respond.
Yeah, exactly. I can respond even if I'm not mentioned if I'm the Republican. Now, what was I going to say? So I would say what Fathom does is it provides statistical models kind of already there. So it's a distinction between modeling and models. And because Fathom gives you kind of ready-to-go statistical models, you can engage in modeling with those models. But I would say both Tinkerplots and Fathom are supporting modeling.
Yeah, just putting a mean in a univariate distribution in Tinkerplots is modeling.
Yeah.
I wanted to ask a little more about what it means to be tidy. It isn't just that there are rows and columns. There's something about those rows and columns that makes it tidy. Can you just refresh our memories of what that is, Amelia?
Sure. So each row, like all the rows have to be at the same observational level. So I think the example that I gave is the one that I always think about. Oftentimes educational, like attainment data comes in a very untidy form where it will come and it'll have a row, which is like the state average outcomes, but then it'll also have each of the counties within each state and their outcomes and each school district within the counties and their outcomes. And so you couldn't just take the math scores variable and take a mean and say this is the average math score for the country, because you're sort of mixing together a bunch of different things that are non-independent. They're nested within one another. So in order to make that data tidy, you'd want to pull it out into a table that was the 50 states, and another table that was all the counties, maybe within each state, or maybe over the entire country, and then school districts, etc.
So in CODAP, we'd end up with the states at the top level, and each state would have the counties and the districts within the counties.
Yeah, but I think, so with hierarchical data, you might have a list of all the states, and then that would go out to a list of all the counties within the states, and then all of the school districts within the counties, and then you'd have the attainment data just at the school district level. You wouldn't have attainment data at the state level.
Well, you could have attainment data at the state level because you can calculate it at that level. And I look at that as being the summarize type of thing that you talk about in transforming.
Yeah. So, but I think that this is, so the data that I'm talking about where you could come up with the attainment data at the state level, but it's not explicitly in the hierarchy, and the hierarchy is nested in that way, that still feels tidy to me. But when you have those like attainment data at those different levels and they're sort of all mixed together in the same column, that's untidy. Or if you had a data set which was about the states and had state attainment data, and then somehow that was linked to tables within that that had county attainment data, and those had attainment numbers as well, like that feels untidy.
So it was untidy to you.
Oh, so that's interesting. So you're saying if there were summary data at each of the levels, so that within that, for all the states there's attainment data, and all the counties attainment, all the districts there's also attainment data. I think you, correct me if I'm wrong, but I think you would describe each of those separate levels as a tidy table. But somehow when they're presented together, it's not tidy anymore.
Yeah, it doesn't feel tidy to me. And maybe something could be done to prevent you from aggregating across levels of the hierarchy so that it would remain tidy. But that's the problem with having the data, like if it was in a rectangular format and it has rows about states and rows about counties, is that when you summarize, the mean attainment, you're going to get a number that is meaningless. And so if you have attainment numbers at different levels, you need to make sure that when you do your aggregation, you're only aggregating one of those groups and not across all the nested structure.
But isn't that what CODAP does?
Yeah.
And I think part of the distinction here is that in this diagram, in the R model, the tidiness is enforced basically at the beginning. You're starting with a tidy table. Then you're going, your transforms can easily and often generally will create things that exist at different levels and so on and so forth, because you're summarizing and so on and so forth. But that's happening as part of your processing model and generating, where you're generating an output. Where in Fathom and CODAP, et cetera, we're essentially presenting, when you've got those separate hierarchical, those separate related quote unquote tidy tables all shown together in a hierarchical display, we're sort of seeing parts of the model, parts of the loop at the same time we're seeing the starting state.
Right.
And it's part of I think this diagram that's in the paper comes from the R model of working with things, where there's a very distinct and clear starting state and then a set of instructions which generate a single ending state, which does not itself necessarily include the starting state anymore.
Sure. And I think you're making a good point about, like one of the weaknesses of R is that it makes it hard to sort of cycle back. I feel like Fathom, Tinkerplot's CODAP all really support the exploration and trying things a bunch of times and iterating. I think I disagree that data comes into R in a tidy state, or that aggregation somehow is untidy. I often will read in educational attainment data, it's rectangular, but it's untidy in the way that I'm talking about. And then my first sort of transformation step, which maybe you could describe as a tidying step, although it takes the form of some data operation, is to break that big table down into smaller tables, which I work with separately. And then the aggregations, those form new tidy data sets, which again, each row is an observation at the same level and each column is a variable. So maybe it's, state means that are computed from counties, but that data set, that sort of outcome data, is separate from the input data. So I'm not going to say I rarely am sticking stuff that I've created back onto my original data. If I'm summarizing, if I'm going from many to one, I'm creating a new data table.
So if you, and maybe this is not the right level to ask the question. So you have a data set with county attainment, and you have a separate data set with state attainment, which has been computed from the county attainment.
Not necessarily. The data, and it's possible that, I'm going to be doing sort of iterations of conversation with the CODAP team, and it's possible that this sort of means that our next iteration should be a full focus on tidy data, and I'll do some more diagrams. I do have a chalkboard in my office, and I could turn the computer if it would make sense to have me draw a little bit.
So I'm, as moderator, I'm feeling us getting too far down into the weeds.
Okay.
And I'd like to up-level and turn to Holly Lynn, because this proposal or this topic relates to what happens in the classroom eventually. And you're working with pre-service and in-service teachers with an eye to what's in the classroom. And do you see this kind of work as eventually things that students do?
So I do think that eventually, so right now in current curricula, there is not much room for things around data tidying specifically. I don't think that most curriculum standard documents kind of at this point in time care about those kinds of things. Do I think they should? Yes. But they don't. And so I think that there's, I think that we have to have an eye towards teaching kids about these different kinds of structures for data. And just like how we have to spend so much time even just thinking about the difference, very simply, a simple example about the kind of data to use for bar graphs versus data for a histogram, right? I mean, those kinds of conversations with kids are really, really important. And having kids really understand that the format that data is in matters in what you are able to do with it. And so I think we just need to think, it seems to me that does something like CODAP need to be able to do the tidying process? I don't know. I guess my experience thus far with CODAP, I'm able to kind of put data in a very flat mode, and I am like things are coming in where every row is at the same observational level, and then by taking a particular variable like state, I can then transform that data into something that looks hierarchical, so they can understand that it has a hierarchical structure to it. That seems very useful to, I think, for students. So I'm not sure if within the kind of table feature or somewhere else, if we need the capability for kids to actually be doing the tidying process within CODAP. I don't know.
Cliff, it strikes me that this relates to conversations you and I have had frequently and recently about observational units and cases. And do you have anything you'd like to say relevant to this or irrelevant?
Well, what I've been we've been talking a lot in designing this hierarchical capability in table. First of all, we haven't really observed, maybe you have on your end now, students trying to really use that with how they might use that and what trouble they might get into. And Rob sort of mentioned this. Boy, if you can grab any variable and push it up to the higher level, you can create really confusing stuff in a real hurry. I mean, it confuses us when I look at it. And so our question has been, one question has been, is this a capability that students will be using at all, or is it kind of for the instructional designer or other people? Could we build some capabilities into the graph itself that allowed this restructuring within graphs or in a more visual way, and sort of and the videos you showed initially, Amelia, sort of reminded me of that. It would be nice to be able to sort of see the result of a transformation on the data in a graph that you were working on instantly to help you sort of say, did this help? I've got a goal. Did this help me achieve the goal? So that's sort of where I've been thinking. And I guess I view our current design as tidy in the Wickham sense, in that we can always pull it back and make a flat table. So underneath in the architecture, we have a flat table. Or that is, we can always get back to the flat table, right? By dragging all of the...
Yeah, I think of in some ways, I think when we moved to being able to restructure the table, the hierarchical structure of the table, I started to think of the table as a view on an underlying flat tile.
Yeah, you can view it that way. But it always is. You can always make it flat. So basically,
right, and so that
kind of interface from a flat, tidy structure into building a hierarchy of any sort.
Yeah, and then by making our hierarchical levels, it's a way of grouping, creating these subtables that Amelia, you were talking about that you make. But I think we do. I think the difference in what the tidying process that Amelia has been talking about and what we do is we still assume data comes in a tidy form.
That's right. We have no capabilities yet that if the data come in an untidy form, that we can easily.
Well, we do have a lot of capabilities in that respect. Because, for example, we have string functions that can take a data set that where a single column represents two variables. We can use the string functions to split that apart in many cases.
Oh, but these aren't easily student capabilities yet, so they're
they are not easy to use.
Right.
It also depends on the type of untidy
they do exist.
So that's part of it. Yeah. And I think the other part would be if one row was state and the next row was county. In fact, I don't even know how you would do that other than manually.
Yeah. Right. It depends on the nature of the untidy.
Yeah.
Right.
I wanted to give Joachim a chance because we've been tidying up data recently as you work to create tidied data that you imagine students working with. Mm-hmm. And what's your feeling as you do this work about what part you should be doing as the curriculum developer and what part students should be doing as part of learning about how to work with data?
I mean, for the data that we work with,
which is very messy data.
It's messy data, and it would be really a great advantage to change the hierarchical structure and to look at at different levels of the data. I have no empirical evidence from observing students how much they should do by themselves and which level. Oh, no, I can't say that. Yeah, no, of course. I mean, with the data I work with, it's always important to have some summarized data and then to look at certain subgroups like counties or how does the variable of interest fare with when you subdivide your population into subsamples. Yeah?
But should students that your group is developing materials for, should they be confronted with the task of realizing that this is not really an observational unit or a case, as we'd say in CODAP, and therefore we need to do we need to transform this data so that we have a more tidy, something more tidy to work with.
Mm-hmm. I mean, I'm not sure if I get what you are asking, but sure, students should be able to change the perspective and to look at various levels of the data, and they should get that idea by themselves. I mean, that's an important step of getting a deeper understanding. Yeah, let's say why do women earn less than men, yeah, and then you have to look at regions, you have to look at positions they have. You may have to look at educational levels. You have to look at branches, and to ask that question is an important step for data science education. Okay, the technology, the desirable technology should support that exploration easily.
Tim?
To give a specific example, in the last 6 months sometime, I was tasked with coming up with data sets using World Bank Sustainable Development Goal data. And if you have looked at that website from which you can download CSVs, you get data at various different levels mixed together if you aren't careful not to have them mixed together. So you get them by country, or you get them by any number of different ways that regions are defined. Maybe it's a continent, or maybe it's the members of the OECD, or something like that. And in order to...
Not even orthogonal.
Not even orthogonal, overlapping groups. And so to prepare the data set, the CSV file that I wanted to upload into into CODAP rather, so that when you did a hierarchical grouping, it would be done correctly, was really hard. And so this question of should students be able to do that? Well, we certainly don't want them to do it the way I had to do it. But do we want to provide some sort of facility for doing this visually, to be able to drag stuff into the right place, to form the relationships between, Andorra is in Europe, but it's not a member of the OECD, and be able to have it work properly?
By hand.
Yes. Yes.
That works. That's so impressive. So Tim said lots of things that are interesting, as always. I think a lot of the answer to this question really depends upon the vision you have about the relationship you see students having with data. Do you see this relationship as the traditional one in which the teacher says, today we're working with this data, or do you see the relationship as a more open-ended one that's kind of supporting a more modeling, problem-solving process where students may go out and find their own data, or teachers may find their own data, or classes may collaborate on data? If it's the latter, this tidy stuff is absolutely essential. That's what to me, that's, I'm still on the fence of whether data science is a thing. But if it is a thing, that thing is going to be more involved in this sort of activity than traditional statistics. Holly Lynn has a really good point. if it's not in state standards or curricula, it's kind of a tough sell in many cases. But I mean, it goes back to what the vision is. I'll just add one thing. I've just been recently reading Peter Huber's book from 2001 or 2 about the art of data analysis or something like that. I don't remember what it's called, but he makes a point that the sorts of things we're talking about where people aggregate across groups where they shouldn't aggregate is, he says, the number one most important untaught statistical concept that is risen in importance when we live in a world now where data are not arriving in this tidy state. So, you know, he wrote that in 2001, and who knows, I imagine it's still true.
Yeah.
Can I just, yeah, I was going to jump in and agree with Rob that I think if the goal is for kids to see data analysis as relevant to things they care about, then it should be possible for them to import data they care about, which is going to be messy. Like, we're all experiencing this. It's going to be messy, and at least have some tools to work with it. I think it might be a discussion among the development team about, I also agree with Holly Lynn that it might not be a major piece of how the tool is used, but I feel like if your goal is that you want kids to want to do this for questions they care about, and the reason that they disengage is because it's just too hard to work with the data, then that's a shame. It's heartbreaking. And so I want to throw my weight behind, if we care about data to make sense of the world, then we ought to be able to get data about the world into CODAP relatively easily.
You, as much
I want to follow up on that, but Cliff has been very patiently raising his hand. So, Cliff, go ahead, and then I'll chime in.
It worked for Rob. It doesn't work for me, Rob.
Which hand did you use?
So I want to take I want to take the opposite end of this consensus that seemed to have developed, and say that tidying data, at least at the level we've been talking about, is one of the most advanced skills in data. And you in order to do it, you have to have a pretty clear vision without even seeing it yet of where you want to end up, of the kinds of things you want to do and accomplish. And if you don't have that, and I would claim most students don't. Most students don't yet know how to interpret graphs or make graphs that they need. If you don't have that, then you have nothing to drive you in the correct tradition. And we have so many goals drive you in the direction of how to tidy data. We have so many unmet goals at a lower level that I would put, at least for many of the students that we're targeting here, I would put the tidying data at a level that if we got to there, fantastic, but we have so many other objectives to get to beforehand. So my sense would be, to the extent that we put these capabilities in CODAP, it's for developers and others. And then we have to ask ourselves, well, wait a minute, do they have other tools and other resources that they could use to tidy data before they put them into CODAP, so we don't build them into CODAP?
Can I push back against that?
That would be my stance. And that if we really want to help students move toward the idea of tidying and the importance, that we take very simple objectives along those lines first, that we don't worry about building in a complete set of transformation capabilities.
So Amelia, then Holly Lynn, and then we're going to have a break, and we're going to come back and move on to the next question.
Okay, so yeah, I want thank you for that, Cliff, but I want to push back against it a little bit, which is I think that you're right, that if you're in that state that Brett Victor was talking about, where you have a program and you have to think in your head, I want to make this change, and then know where to do it in the code, and then see what happens, and hold those states, that is a really challenging thing. And certainly when I'm doing data tidying or data cleaning in R, I often find myself running a piece of code and then looking at the output and going like, oh God, now I just have a column that's all commas, and I wanted the part that wasn't commas, or whatever it is. And so I think that is a place where there are some tools that are doing this visually, but if you had a way to shorten that loop that Brett Victor was showing, and instead of having to compare the states in your head and remember the connection between the code and the output, if you could manipulate a data transformation and see like, oh, if I do the break here, it's going to be the part of the text string that I want. And if I do the break here, then it's all the commas, which is not what I want. And you could see that visually. I think that would be a powerful tool for anyone. And I could talk about some examples of things that are out there that are moving a little bit in that direction, but there's very few tools that allow you to break that sort of loop of changing things blindly.
Holly, I think you had something to say.
Well, and actually most of it has been said, I think, both by Cliff and Amelia, that I think we're struggling with a really tough issue of who is the user of the potential tidying, and who does it need to be made for, and who is really going to use it. I do agree with Cliff that at the at the very highest level of those that are comfortable doing stuff with data and statistics in their classrooms in K-12 settings, most of them, are they interested in going and getting messy data? Yes. Do they have some skills to do it? Yes. Are they willing to necessarily put it in front of their students to do that? No. And so if we could make something where it would be easier for them to tackle some of these low-hanging fruits of tidying kind of skill sets, maybe not all of it, but being able to teach them some of it, I think that would be fantastic. But I think we have to keep the audience in mind, but build it so that it's easily expandable as the importance of data science experience comes down the pike into K-12. I mean, it's starting there now, but it's we've got to we're barely making progress in just calling things statistics in K-12.
Yeah.
Okay,
Michelle was burning with.
Yeah, I wanted to bring it back to the platform conversation, because I think that influences, and that's sort of what Holly Lynn was talking about. So if it's a platform, then the users are people like designers, perhaps, or are people like teachers, perhaps, and not just students. And so to what degree on the platform level do you want to make this facility, which we know is pretty hard for everybody, available, even if the kids aren't the end users at first, but could benefit if they're interested in this. I mean, I would love it for myself. Audubon Society data is really messy too. Like, it'd just be useful for that set of users.
Okay, let's take a 5-minute break. So nominally, we'll be here again at 10 after the hour.
Okay, are we gonna leave this going?
Yes.
Okay.
You can turn off your video, turn off your audio if you so desire, or not.
Okay.
I mean, you worked with, you downloaded data on sustainable development?
Yeah.
Wonderful. That's just what
I thought
to be.
Oh, you were in my workshop.
Yes.
Because we used the sustainable development data in the workshop in Berlin.
Okay. I downloaded some data from the United Nations about human development indices, and of course, I mean, there are plenty of very interesting data available, but to make them really accessible is a lot of work. And sure, and they are also hierarchical, because some of the data are time series data and other data are...
There's also the time series issue, in addition to the regional issue.
so I did not pay attention to the time series issue, but for me that was quite a bit of work just to get, say, 30 variables across 100 nations into one comma separated file that I could input then in CODAP. And of course, I mean, it's impossible to expect that from any student to do
that way. And so the question is, can we make better, more visual tools to be able to do the most common things?
Okay, I mean, that would not only be helpful for students, it's
pretty helpful for all of us. We can make it easier for us as well. Right.
I mean, the other alternative then just would be that we provide curated, cleaned up data sets.
But that doesn't get to students getting their own data.
Okay.
Right, going out and finding the things that they are interested in. Yeah. So that's where we can do what Tuva does not. Tuva is very interested in the curated data sets. And I agree. I think we want kids to get their own stuff.
Yeah. But
we need to go fix the telephone.
I mean, and we cannot get these data providers to clean their data up before they put them online.
It sounds like an even harder task.
I mean, they have to realize their mission is also to educate the public, and not only economic leaders and politicians.
I think
the issue there is that the data providers haven't themselves had any classes in tidying data, so they have no idea what formats to give.
Yeah.
Well, and I would say a lot of people who are putting data sets up online are putting them up for other researchers, and they assume that, you know, the people who download them will have the skills and actually make the kinds of decisions they want to make about how the data gets cleaned. Because one could imagine that, you know, you give the same data set to 5 different people and they go clean it, and you don't come back with identical cleaned data sets because they've made different kinds of decisions about what they thought should be filtered out or that kind of thing. Yeah, it would be helpful if we had a listing of all of the, like, what are the typical data cleaning operations.
But that's data cleaning.
I know, but well, to get it into this tidy state, which is it's a combination of the breaking the columns, if there are things at different hierarchical levels that are really listed in a flat way. I don't know what other operations there are, and you know, if we had a listing of them, we might say, well, here's some low-hanging fruit. There's interesting things we could do here. And, you know, here's other things that just feel like you need to have advanced skills to do them, and they're really hard for us to do. And if they become important for a particular project or partner, then we can work on them. But
I think it's, from most of us, keeping tidying from cleaning separate feels somewhat artificial.
Yeah.
Because what we start with is both in need of tidying and of cleaning.
Right.
And I wanted to chime in on that because I think kids absolutely should be engaged in cleaning. You know, seeing that, you know, data comes in a, you know, they bring it in and somehow, you know, maybe they bring it into Excel and it changes something into a date format, you know, whatever. And they've got to figure out how to get it back into the format for the usability for what that variable is supposed to represent. You know, they need to take out $ or text spaces that were on a website or something like that.
Right. How do you handle missing data?
Right.
I wanted to ask Rob a quick, well, it's probably not quick, but a question.
All right.
You've developed a data science course. To what extent is cleaning and tidying a part of that course?
Well, less than we'd like it to be, because they don't have a really large, I mean, so we're using R and there's a lot to teach there. But I think, you know, I think the way we've approached it, if not explicitly then implicitly, is to get at this issue of what is the case. Mm-hmm. And we've so far been talking about some kind of hard things, but they're really simple examples of that, which we rely on in this course, which is, you know, based around the notion of the subset function in R. You know, is that often what you need to do is you really are just extracting rows to recognize that some cases are not equal to other cases, that some cases don't belong in your population or your inferential universe or something along those lines. We really haven't tackled the hierarchical problem, which is a big flaw in our curriculum, because it does come up. But again, I mean, I think that the way of thinking about that is always to say, what is the case? The one exception to this is we do talk about merging. It hasn't become as big a part of the culture of the course as we hoped, but we do teach them how to merge files and give them examples of when they might want to, and have an exercise where we ask them to find a file to merge or something like that. And I think that's part of this tidying aspect as well, is to recognize, you know, I've got data on the kids in my school and data on kids in another school, and now I want to find data about the schools. Can I merge that data with what I've got? It would be great. I mean, as Cliff points out, like the thinking always kind of, and the technical and the doing just kind of interact in a very frustrating way, and I'm never clear quite what comes first. But what we haven't achieved, and I'd love to achieve, is to get students to want to find that data and to be able to say in a sentence, I want to merge this data. Can you help me merge the data? But they don't have that concept of merge, so they don't ask that. And I think that would be a success for us to get to that stage, and then we can help them merge. So I mean, I buy Cliff's point that that some of this is really hard to do unless you know what your analysis is. I mean, that the data scientist cycle there is, like all such graphics, is oversimplified, and there's a lot more arrows, a lot of arrows missing. But at the other hand, I mean, I think focusing on that notion of what is the case, and we've given some good examples, but I mean, I think one example we haven't really given is, which I think is quite common, is students collecting, and this is what we're using in our course, which we're not tackling well at all, is students collecting multiple measurements on themselves. So right then you have this nested sort of sense, and some students will collect 2 measurements and some will collect 30. Are you going to take their average of the measure? So what's the case there? Yeah. And you need some tool right away to kind of get at that.
You may see that Kirk chatted a proposal. Would you like to say anything about that, Kirk?
Wait, how do we see that?
You press the chat button. You should, or the where.
Oh, okay. The reason I chatted it rather than something else was A, we were going to break, but B, it may be at too low a level to be worth bringing up at this. But it was the thought that was provoked by the conversation we were having, and in fact, it directly relates to the selecting, the part of the tidying process that Rob was just referring to, a way you could allow a separation of the cases you do want, or the rows you do want, from the ones you don't want.
So, Talia, could you copy that and put it into the discussion document?
Sure.
Yeah, I could have put it there too.
Yeah.
I also
will have it. You wanted to say something, Dan?
Yeah, so this, well, it's linked to this, but I think it's linked to a bigger idea that I'd like to get into regarding the paper and potentially transformations. So I was thinking about what would be visual ways in order for people to be able to do some of the kinds of, you know, operations that we just talked about. And because, you know, I think I was looking at, you know, when I read the paper and I saw all the transformation section, I said, CODAP does all of these. It already does all of these, and some of them are more visual, with like dragging columns around, and some of them actually the functions are there, but you have to create a column that has functions. And I was trying to figure out if, it feels like one of our goals is to try and make this stuff more accessible to kids. And I think anytime it requires them to create an equation, to do some kind of transformation operation like filtering, something where it's not actually multiplying by or, a mathematical operation, that maybe we could figure out a way to do something like that in a different way. And so,
let me interrupt there just a second, Dan, because Michelle has been working on alternative ways for kids to change structure and represent structure for a long time now. And your tools have been very visual and Brett Victor-like, if I may say so.
I have read and been informed by some of his techniques, yes.
And how do you find that working with kids?
It works. What we're finding, I'm organizing my response in my head as I talk. One of the things we found most recently is we've finally gotten, data sketch in shape to put it in front of kids and have them create things. So we give them a data set of weather over the past month or so, and just ask them to explore relationships that they think might exist. So, maybe increases in cloud cover have some relationship with rainfall, maybe temperature has some relationship with cloud cover, that kind of thing. And you have to be very careful in how you prepare them. And I think you prepare them by having them hypothesize about the relationships that could exist and what it would look like if those relationships are there, what it would look like if those relationships are in fact not there. So it's sort of a lot of prep work, not necessarily with the data itself, but it's the modeling aspect. It's getting them to treat the exploration as modeling data and looking for relationships in data, I think.
Before we move on to the second question, Amelia, would you like to pull back from your provocateur role and say anything in a summarizing fashion about this discussion so far?
I'm not sure. So one sort of, I don't know if it's quite a summary statement or not. I put a few notes at the end of the Google Doc about the difference, my sort of definition of tidying versus cleaning. And I think that there was more debate over whether students should be tidying data, in my definition, than cleaning data. I heard quite a bit of consensus that cleaning data is maybe something that students should be able to do if they're going to work with messy data. And then just to respond to, was it Jonathan who was talking about? No, Dan, recently talking about how CODAP has a lot of these sort of transformation functions. I think that's true, that they're all there in, they're possible, but to me they feel like the before, the Brett Victor before scene even more than R does to me. Because if I make a mistake in R, I can hit the up arrow and edit the code and hit enter, and hit the up arrow and edit the code and hit enter. And with CODAP, I go in, I don't have any tab completion, I don't have any documentation there about what arguments a function might take.
This is all coming.
Yeah. And I mean, at the very least, I would like to be able to say apply and see what's going to happen, and then try again and apply. Because to get it to happen, I had to click OK, and then I'd have to go edit it again. Mm-hmm. But I think that there's possibility for even more visual, like immediate views of some of those data transformations. Like I think the hierarchy function, like dragging things out to form a hierarchy, is sort of a group by operation. So I think that's really powerful. And like sorting, that seems like it's already a visual operation. So it's more the mutate, what I'm calling the mutate function, where you might edit a variable that already exists or create a variable using a formula. That seems like the part where it's not visual in CODAP yet.
So thank you. And I propose we move on to the second question, and I'll kick it off with a question for Amelia. So the question is, are the elements of the cycle fully inclusive? Are there other components that have been left out? And I did not understand if the following example is covered by those elements. And it's a classic example that comes from a paper by I'm blanking on his name, Cliff. My mind is completely spaced.
Well, give us the example, maybe.
The example is you have students are measuring each other's heights, and they're putting the data into a table, one column of which is labeled boys, and the other is labeled girls.
Chris Hancock.
Thank you. And this is, I would assume, completely untidy because the rows don't represent a case. And is one of the elements in the, or one of the things you talked about, able to transform that so that we have rows that have gender and height as column headings?
Yeah, so I didn't talk about that specifically, but that would fall in the Wickham tidying category of getting something so that each row is an observation and then the variables are the columns. So having one variable that's gender and one that's height. And there are operations in R, in actually the package called tidyr, which I believe are called gather and spread, which help transform long, tall data into wide data and vice versa. Sometimes you need one or the other to get data to be tidy. I didn't talk about those operations, but I think they're really important as well.
In fact, Jonathan is midstream in creating a CODAP data interactive that gives you the ability to do this interactively as close to the Brett Victor paradigm as we can reach with the resources available to us. And the reason we've decided to do this is because it comes up so frequently in working with collaborators that their data is in need of this kind of gathering. What was the other word?
Spread.
Spread. We've started calling it stacking.
Yeah, it was stacking.
Yeah.
Okay.
This totally reminds me of, I mean, the three kind of basic graphical operations that Cliff has in Tinkerplots of when you have all the data kind of in the graph, you can stack, you can separate, and kind of those basic ways to start constructing graphs. You could think about having those basic operations being able to operate on a table of data.
Very cool.
In some ways, Bill, that what you just described, it's like a list of boys and heights and a list of girls and heights. So if you took those as two separate tables, they're two separate tidy tables. But you want to merge them into a new form.
Yeah, I mean, this sort of thing happens all the time in data science. Like, I think in genomics data, when you have a bunch of genes, for whatever reason, people who do gene sequencing always give you the data in either the tall or the wide format, and it's not tidy. And so, like, doing these kinds of operations, it's more than, in that example, there's just two, but there might be like 50,000 things that you need to sort of shift the relationship and turn things that are in the data into variables in weird ways.
It does sound, in the way that you're talking.
Rob was talking, but it was muted. Rob, we still don't hear you.
Okay.
There.
Thanks. for noticing I was talking. That's impressive. So the other place this comes up all the time is the TI calculator requires that untidy format, in fact.
Yes.
And I believe that Excel's tools usually make it easier to use the untidy form where you'd have the boys and the girls in separate columns. So if nothing else, giving teachers an easy tool, because a lot of them probably have these data sets already in this horrible format, to be able to convert it back to the tidy format would be a nice boom.
Michelle?
It just, in the way that you've been talking about tidy more recently, it does sound pretty linked to conceptually to ideas of data analysis. And so I do think it could be, there are ways to connect it to the kinds of activities and questions we want kids asking. And I just wanted to point that out. It's not just a technical, at first it kind of sounded like cleaning was more conceptual and tidying is this technical manipulation to get it in the right format. But now it seems like it can be linked to these conceptual ideas of looking for relationships or taking apart the presumed relationships and stitching back together.
It occurs to me that a natural extension of this question would be, are there data structures that don't lend themselves well to tidiness? And I'm thinking of linked pointer structures, networks, semantic networks, or social network representations.
Genealogy.
Genealogy. Do these things come up? Should they be part of our discussion about working with data?
Are you asking me?
You're a prime candidate.
So I'm not sure. I mean, I think, so I don't know much about genealogy data. I have done some network analysis, and there are ways to represent networks that are tidy, and there are ways that are untidy. And so again, I think that it's a question of having the ability to move between those formats. But you were asking, are there structures that don't lend themselves to tidy formats? And in my mind, like JSON or XML data is another common way that you find data on the web, other than CSV files or Excel files or whatever. And that data is highly structured, and it's hierarchical, perhaps in a way that is not exactly what CODAP thinks of as hierarchical. It's maybe not tidy. It probably needs different data operations, but it's very common and has good data properties.
So sort of arbitrary data structures.
Yeah.
Essentially, JSON is capable of expressing any data structure. And
including tidy ones.
Including tidy data structures, yeah. And do we see as part of what students should be doing, as part of what CODAP should provide facility with, an ability to work with arbitrary data structures?
I'm not committed enough to that to make the provocation that CODAP should work with arbitrary data structures.
But if we are creating tools to make nearly tidy things tidy, it seems reasonable that we might think about including ways to make these more arbitrary data structures tidy, like to find the tidy parts within a JSON file because it's easy to download them. People might find them. And if we, if I could see something that showed me what are the attributes in this JSON file, and can I drag them to make them correspond to the attributes in my output file?
So Tim, I can send you an example of a JSON file that I was trying to get to work in CODAP and learned from Bill is maybe not the sort of data that CODAP is designed to support right now. And you can see if that helps solidify your thinking about this.
Well, I certainly believe that there are files that will not be easily made importable. But I have seen files that can be made importable if you know what to select.
Yeah.
So we can help students see a more arbitrary data structure and find the part of the arbitrary data structure that's not as arbitrary. And I would see that as useful, both for us as instructional designers and for students who would find their own data.
Historically, we've thought of that as more part of the import process. And so, for instance, we would extract the table from an HTML page.
Exactly.
Existing example from Fathom of where we do that sort of thing. We don't give you tools for extracting tables from web pages internal to Fathom or CODAP. But at the import step, we make them. And there are other things. And in CODAP, you can do those things, as has been discussed, at the data interactive level. Make it part of the, configurable how you get data in, after which you can then start the rest of your cycle.
But by the way, it would be very helpful, not only for us, for others, if we could build a library of examples of data structures and formats that we could refer to when we're trying to make these decisions. And I mean, we've all come across them, but I'm not aware of anyone sort of making a collection of them and even trying to label them. There probably are some in some library of data structure stuff, but I don't even have a vocabulary for most of the problems I run into.
I think that's a good point. Just for purposes of discussion, I did paste some JSON data into the bottom of the Google Doc so you could look at the sort of thing that I'm talking about.
And when we were thinking about data structure in what is now CODAP, but was data games, it was the naturally hierarchical data that came from playing games. That each game had moves. And that led us to say, well, we need to be able to work with these two levels. And once we got going with it, we said, well, maybe we need more than two levels. And maybe it shouldn't be a rigid thing that you're presented with, but something that you can change. And I think we've been surprised at how surprising that is, and how much you can do with that, and how much it draws attention to the question, what is a case? Because a case is different at each level, and therefore is a tool in the classroom for helping students to grapple with what is a case in a way that having only one level doesn't. I think in my own mind, I've not thought about going farther with other data structures, partly because it seems like enough. It's when you're learning a language, the first language you learn teaches you something about language in general. The second language you learn something about language in general. And I think of hierarchical structures as teaching you something about data structure in general. And that's, in my mind, a tremendously useful thing and something I'd like students at the school level to deal with that they don't currently have to deal with.
And giving them the option of grouping it any way they want is a way of pedagogically getting at what Rob was saying earlier about how important it is to understand that some of those are useful and some of them are really, really bad. And the fact you can play around with it and see which ones work and which ones don't is a way of surfacing in, the mind of students what makes something work and what makes something not work, and those invisible grouping. What did you call it? The most underappreciated problems.
The power of being able to make a mess. Anything else people would like to say about this second question? Second question, I should say. Okay, the third question is, should CODAP provide all the data transformations of a professional tool like R? And we have been talking about that all along. Is there anything you wanted to provoke us in particular about, Amelia?
I think the only thing, which I probably wrote in the paper, although I haven't looked at it since I sent it last week, but there's this idea in the dplyr tidy data cycle of doing summaries. And summaries are these many to few or many to one collapsing sort of actions. So maybe you want to take the table and you want to know how many rows there are, and so you're collapsing the number of rows in the data set into just one number. Or you want to know the mean of height for each gender, so you're collapsing your data set into two numbers which are computed on different groups in your data. And I haven't figured out a great, and this is probably, I don't know much about the functionality of CODAP, but I don't really know how to create those new, they're sort of mini tidy data sets that are created from other larger data sets.
So I'm going to show what I think you're getting at with an example, one of the example data sets. Mm-hmm. Mammals, so each row is a mammal. And it's flat now, and I'm going to make it hierarchical with habitat at the top level. And I might pause to ask Rob if I've already created a mess by doing this arbitrary regrouping. Rob isn't jumping in, so I'll assume not. And then I'll say, I want to find...
Cliff, will you do me a favor? I mean, I'm not Cliff, Bill. Will you do me a favor? While you're doing that on the table, I think it might be useful to also show how it's related to what you can do graphically. I mean, because thinking about if there is a particular variable that you have graphed and that you would put, you would put land on the y-axis. We're now looking at that particular variable subgrouped by.
Right, you have choices on whether you can use, even before it's grouped, you can use the visual cues in graphs.
Yeah.
Of the grouping without actually restructuring the data table.
So I think what you're getting at, Holly Lynn, is here I make this graph, and now I regroup. And instead of 27 dots, I've now got 3. Mm-hmm. So that's kind of an indication of what's going on. Mm. And what I wanted to show next was that if I can compute an attribute at the habitat level, which I'll say mean sleep. And here's type ahead, maybe recently got implemented. And I misspelled sleep. So I'll compute the means of sleep, apply that, and now I've got a new attribute at the, I've done a many-to-one operation.
Yeah. So this is worrying me because now you're getting untidy. What happens if you ungroup by habitat?
Now wait a minute.
Yeah.
This isn't untidy, is it?
Well, each of the subtables is tidy.
Yeah.
Yeah, but what happens when you ungroup by habitat?
What do you think?
Hopefully that mean sleep variable disappears.
Or it could be property.
Hopefully it gets replicated across.
Yeah.
No, hopefully it gets replicated across all the lands.
And that's what tells you this is still inherently tidy.
And I'm looking at Jonathan because I think neither of us really knows.
All right, Bill, you're going to have to do it.
Go ahead. Go ahead. I think it'll be fine.
Jonathan's more confident than I am.
So now it's giving us the mean of everything because we have a.
And now pull mean sleep back in.
Well,
And that's for everyone.
That's for everyone because there's only one group now.
Oh, yeah. I wonder if you'd have pulled it before.
Now, this is something that Amelia mentioned. Here we have the same number repeated because it's computing the mean of sleep over all the numbers.
Well, because
but that number is different than it was when it was pulled out.
I was afraid you'd notice that, Holly Lynn.
it's different. I can't see the value.
Right now it's 10.79, and if I undo that,
it was 11 something.
Oh, but no, it really must have been 10.7.
I saw it too.
Land number.
It was a refresh bug.
Evangeline just said from the other room, remember she's QA, I'm going to write that up.
And Bill, on the graph also, can you show how you can also get the mean for the groups now that?
Sure. So I'll put habitat back, and I'll put
I was thinking
here, and create another bug.
Write that one up too, Ben.
Oh God. So here I've got diet. Let's do it with diet and sleep, and then show the mean. So this is another many to few operation.
Yeah.
It's also worth remembering this. In Fathom, we had a more flexible sort of summarizing option. You could anything you could put into a summary table by formula, you could then create a separate collection from that summary table.
Right.
And start over from there.
Yes.
Now, Bill, what happens now that you have that graph that has those three variables, sleep, diet, and habitat? If you pull habitat out in your table,
that's guaranteed to explode.
Go ahead, Bill.
I was going to say, I think it would still do the same.
Yeah.
Okay.
So it's easy to dive down into things that CODAP can and can't do and finding bugs, but I'm going to stop sharing. Not because I'm embarrassed, I'm not. Finding bugs with friends like you guys is the way we want to find bugs.
It's too much fun. We wouldn't talk about anything else on the list if we started doing that.
We can do bugs with friends.
Back to the original
cool drinking game.
I sort of feel like for questions like 3, the answer is almost self-evident. That it ideally yes, in practice no way.
Yeah. Which one is 3?
Should it provide all the capabilities of R?
Oh, and say your answer again. I was trying to find 3.
Yes, in practice, no way.
Well, I disagree that ideally it should.
Yeah, I'm not sure it should either.
Well, I wanted to get the definition of like R. Like in the way that people interact with data, in the way they do with R, or just mean.
Oh, I just meant, I didn't mean all the capabilities of R. I meant all the data transformations that I listed there as the verbs from dplyr. So group by, select, filter, mutate. I'm missing some. But those sort of data transformation functions. And I believe, yes, those should all be possible in CODAP.
Plus some of the other ones you mentioned, like spread and stack and...
Gather.
Yeah. I wasn't thinking about gather and spread because I was sort of stuck on transformations, and that seems like a tidying operation to me. But yeah, people seem to be convinced by the gather and spread thing too. Sounds like it's already on the way.
I would say that with regard, well, I should bring us on to the next question. Who would use CODAP if it had these features, and are those the users we are targeting?
Did we skip one?
Did I skip one? Oh, variability. Can I skip that for a second?
Sure. Yeah, I don't know that we have time to talk about all of these questions. How long are we on here?
We're going to
about 15 minutes.
In about 5 minutes, we're going to have the process discussion about how did this go and should we do it again, that kind of thing.
Okay.
So back to the P in CODAP. What I'm taking from this discussion is that one of the users that we have are these collaborators who are going to build on the platform. And if they have to go to R all the time to massage their data into a form that they can use in CODAP, then they won't be using CODAP as much. And one way to get people thinking deeply about how to use a tool is to make it something that's useful to them. And so these capabilities, first of all, that we would like in-house, but secondly, our collaborators like Holly Lynn would like, making them available at that level can deepen the collaborations and strengthen the collaborations and help CODAP get disseminated and used in the real world. And because they're being used at that level, then people start thinking about, well, what should students be doing? And if we make them friendly enough and dynamic enough, then people can imagine students using them with understanding.
Mm-hmm.
But if there are like, in that you write a program, then most collaborators will say, well, I don't want middle school students having to deal with that. We'll just produce curated data sets.
Yeah.
I'm stepping back into my moderator role now. What do people think?
I agree. I mean, I think that we have to have the eye on both targets, and that that you want a tool that has capabilities for developers. And I mean, my goal is to keep pushing you all to develop CODAP in a way that teachers and students can pick up and use it without it being built into other people's products. And so I like that continuing to be part of the conversation.
Mm-hmm. Because you, unlike some collaborators, imagine CODAP as it is an environment in the classroom.
Right. Because, I mean, what one of my hopes and dreams is that, I mean, you know, I've spent over a decade, I was going to say decades, but it hasn't been two, over a decade, you know, using Fathom and Plots, and then my teachers get frustrated if they don't get access to that out in schools. Well, having something that is online is extremely exciting, that I can actually help my teachers come to understand statistics and data capabilities better with the tool that they will have access to when they go into their classrooms. That's how I'm going to impact change in classrooms.
Mm-hmm.
Yeah, I would say that, so my concern about having the eye on both targets, or maybe a strategy for doing it, is that I know that for a long time our goal has been to make it possible for students. And when I think students, I'm thinking middle and high school students primarily, but I would even say this is true for most college students, that there's an intuitive environment for doing data analysis, that they are not having to learn. There's not a big learning curve to get to being able to do most of what they want to do with the data. And so my concern about, including lots of advanced features is that then the UI gets so complex that it becomes intimidating and difficult for a lot of people to use. So, one of the things might be that while at the same time we think everything should be, visual, manipulation in order to get things done, it might be that some kinds of advanced features are better relegated to the function world, where we can add however many functions we want, but most kids aren't going to know what they are or need to see them, and it doesn't get in the way of the UI. But every time we design like a specialized UI for breaking up rows into multiple, selected categories and hierarchical levels, like that ends up adding visual confusion to a feature that, 1% or less may end up using regularly. So that's the balance that I would say we need to consider in terms of developing what I think of as the CODAP product part, right? The thing that Holly Lynn is talking about, she wants to use out in the classroom. And I think the thing that many of our partners have been interested in using CODAP in some way, like adding in a data interactive, you still get most of the UI of CODAP if you're just building a data interactive.
So I guess I understand all the issue. I mean, I understand these tensions and all are natural parts of everything. I guess I would like to make sure that the choices you make position you well for the future, because I think what we're developing here is a vision of data analysis that isn't yet implemented in classrooms. And so when you start to talk about keeping making it accessible and intuitive for data analysis, I mean, I think what I see Amelia talking about is still data analysis. It's just kind of expanding the scope of that. And I understand, to use maybe misquote Cliff or something, I mean, he once gave a talk, I remember, at SRTL about the notion that, when you choose a case, you are performing an act of modeling. So it really gets back into this idea of where do we begin the modeling process in the classroom? And right now we begin it after that early stage of understanding the data generating process. And now what I'd like to see happen over years, I imagine, is pushing back that process so it starts earlier and earlier, and the modeling starts earlier and earlier in that process. So I understand completely you're going to have to make decisions about where you see that process beginning, but I would like to see a flexibility, because I think hopefully over the next few years that will expand quite a bit.
So there's momentum here. We could keep talking, but we agreed we would stop at that hour. Just reflecting briefly, this was for me a very stimulating, thought-provoking discussion. And I thank Amelia for giving us something to chew on and help us prepare to talk together. And thank all of you for having read the paper and thought about it and being willing to discuss it. Now, we will probably do this again. Another round of Amelia taking on some topic, writing it up, and then bringing together a group to talk about it. Are there things you would suggest we do differently next time?
Well, yeah, I mean, I think personally, I would rather have several shorter sessions than one longer session. So I'd be much more likely to find an hour a week than 2 hours every other week to be able to. And also, I just might focus the discussion a little more.
What about 2 hours every other month, Rob, which is the scale we were thinking of?
It's just really hard to find 2 hour blocks of time. If that's what we have to do, that's fine, because I understand there's an advantage to being able to flow a little bit more. But also, I mean, if having shorter conversations where we can think between weeks or something like that would be nice. I'm not advocating for every week.
I guess I would have appreciated perhaps being able to submit some of the question topics.
Say again, Dan.
I think I would have appreciated perhaps having the opportunity to submit the question topics that might be discussed at the meeting.
Uh-huh.
I'm not sure. Yeah, I mean, these were fine questions, but you know, there were other directions I thought maybe the meeting was going to go.
Uh-huh.
Well, I really enjoyed this. This is fantastic. Just to be pretty blunt about it. Just this number and this number of differing perspectives, which we don't often have in our meetings anymore. I really value.
I appreciated all of you being respectful of each other's time to speak, and nobody hogged the floor. Thank you, thank you.
Moderation.
And we will do this. I'm convinced we'll do this again if Amelia's willing.
Yeah.
And I don't know what the topic will be. We haven't talked about it. So we may even solicit, may send out an email saying, are there topics that you would like Amelia to think about and the rest of us to talk about? And of course, you're under no obligation to come the next time around. We'll send, I think this was a very good number. I was surprised at how well it worked. The video seems essential. Thank you, Holly Lynn, for getting your camera working. So we don't want it to be a huge, much larger than this. You'll certainly be invited. Some other people who were invited but couldn't come will be invited again. We'll aim for about this size. And I don't know exactly when it will be. It might be a month, might be 2 months from now. But it's not going to be every week. None of us, at least here on the team, could stand that. So send other comments that occur to you about how to do this, and maybe we'll put together, we'll send out an email with all of you so that you could use that to be able to send out any comments that you wanted everybody to hear or read. But we're not starting a discussion list today. Thank you.
Thank
you.
Bye.
Bye.
Take care.